All right, let's talk about one of the biggest frustrations in crypto today, gas fees. We've all been there. But what if you could use crypto apps without ever having to think about them? Well, we're going to dive into a really clever solution called EIP-2771 that's quietly making that a reality.
So let's just start with a really simple question. Have you ever gotten really excited to try a new crypto app, only to hit a brick wall almost immediately? Yeah, it's an incredibly frustrating experience, and it turns out there's a very specific reason for it.
We can call it the gas station problem. And it's this kind of vicious cycle, this chicken and egg thing that traps users before they even get a chance to start. Honestly, it's a massive barrier for bringing more people into this whole world.
I mean, this flowchart basically says it all. This is the new user trap. You see a cool dApp, you want to try it out. But wait, you need crypto for this thing called gas. So to get that, you've got to go find an exchange, sign up, buy some, and by that point, that initial excitement is just gone. You abandon the whole thing. It is a huge drop-off point.
And the reason this whole problem exists is pretty fundamental. The best analogy is a car, right? You can have the coolest car in the world, but it is not going anywhere without fuel. On the blockchain, gas is that fuel. It's the fee you pay to get your transaction processed, to pay for the computation. No gas, no go.
Okay, but what if you could just skip the gas station entirely? What if the app itself could kind of handle the fuel for you? This is where our solution comes in. So let's talk about something called meta-transactions and the standard that makes it all work. EIP-2771. So a meta-transaction, the idea is actually brilliantly simple. You, the user, you don't actually send the transaction yourself. Instead, you just sign a message saying what you want to do, like I want to mint this NFT or I want to cast this vote. Signing that message is completely free. Then, someone else, we call them a relayer, takes your signed message and they pay the gas to submit it for you.
And here's the difference right here. The old way, the entire burden of gas is on you, the user. But with the EIP-2771 approach, the user experience is just transformed. You just sign what you want to do, and the complicated, expensive part is all handled for you in the background. It's a game changer.
So, how does this all actually work without, breaking security? Let's pull back the curtain a little bit and look at the clever mechanics that make this whole gas-free experience possible.
To really get it, we need to meet the key players. So you've got the user, that's you, and your only job is to sign things. Then there's the relayer. Think of them like a helpful concierge who handles all the payments. But the real magic happens with the trusted forwarder. This is a special smart contract that acts as a secure, bonded messenger. And finally, you have the application's contract itself, the final destination.
And it all comes together in this pretty simple four-step process. 1. The user signs their intent. 2. The relayer pays the gas and sends it off to that trusted forwarder. 3. And this is the most critical security step, the forwarder contract verifies that the user's signature is legit. And finally, once it's verified, the forwarder calls the destination contract and carries out what the user wanted to do in the first place.
Okay, so this leads to a really important question. If the relayer is the one actually sending the transaction, then the MSG sender is going to be the relayer's address, right? Not the user's. So how in the world does the contract at the end of the line know who actually authorized the action?
Well, here is the secret ingredient. It's actually a super clever bit of data handling. The trusted forwarder just adds the original user's address, all 20 bytes of it, to the very end of the message it sends. So the destination contract is programmed to check, hey, is this call coming from a forwarder I trust? And if it is, it knows to look at those last 20 bytes to figure out who the real user is. This is all handled by a simple function usually called _msender.
Okay, so we've covered the technical how, but now let's get to this so what. Why is this such a big deal? This is where the tech really translates into real-world impact.
The benefits here are just huge. The most obvious one is the gasless user experience, right? It just completely removes that onboarding friction. But it's also secure because it's all based on cryptographic signatures that can't be faked. It's also replay safe, which means a bad actor can't just copy your signed message and submit it over and over. And critically, it's a widely adopted standard. Big platforms like OpenZeppelin use it, so you know it's battle-tested.
And listen, this isn't just some theoretical concept on a whiteboard. Developers are using this standard right now to build whole new kinds of applications that honestly just weren't very practical before.
Just look at these use cases. For onboarding, it's a complete game changer. For gaming,
Imagine players actually focusing on the game instead of approving a transaction for every little in-game action. It makes minting NFTs so much smoother and less intimidating for new collectors. And for DAOs, it means community members can actually vote and participate without needing to hold the specific token for gas.
So the crucial takeaway is this. EIP-2771 systematically dismantles the single biggest barrier to entry for new crypto users. It separates the action you want to take from the fee you have to pay, and it creates a user experience that feels so much closer to the normal web apps we use every day.
And that leaves us with one final thought. By taking away the cost and the complexity of gas, EIP-2071 doesn't just improve the apps we already have, it opens the door for entirely new ideas. It forces us to ask a really, really exciting question. What becomes possible? What will you build when gas just isn't a barrier anymore?